Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video. All math-based, of course, and as always, it is an honor and a privilege to be serving you today as it is every day here in my virtual classroom. Step on inside. Section 10.7, circles in the coordinate plane. This is in the Big Ideas Math Integrated Math 2 textbook. It is the last section in the Chapter 10 bit on circles. Chapter 11, I said this before, I do believe begins with more circle talk, circumference and area and things like that because they get into volume of solids. And when this video series thing kicks into that, then you can check that out. But this is circles in the coordinate plane is going to look different from all the other things we did in this chapter when we hit tangents and secants and arc measures and things like that. No. We're looking more at the equations of graphs. We're looking at some more algebra stuff. And actually in section 10.6, we did do some algebraic things solving quadratic equations a couple times. Here, I don't know if we're going to solve quadratic equations, but we're going to set some things up with quadratic equations. And that's at least what I expect to do. And I know that we have a bigger set of problems. Hopefully that means they're quicker. So who knows? Your guess is as good as mine. You know more than I do. This video is now recorded by the time you watch it. So I'm watching it. I don't know how the future looks. But let's go and check out the lecture portion. If you want to follow along, go to the description section down below and download the PDF and check out the timestamps where you can find certain things. I begin with a lecture portion from the Big Ideas Math Integrated Math 2 textbook, and then we hit the numbers 1 through 60 something. So without further ado, let's go ahead and get started. Let's take a look the new vocabulary standard equation of a circle. I believe I also call it standard form. Other places might call it general form. So I think standard form is generally what I would say. Completing the square is going to be used again, and I guess it's a I'll talk about it, but I don't really feel like teaching it again, if that makes sense. So I'll do it. It's based on some algebra stuff we've done before. It was previous, after all. We're going to learn how to write and graph equations of circles, how to write coordinate proofs involving circles, solve real-life problems using graphs of circles, and solve nonlinear systems. I didn't realize this would be actually a part of this part, but that actually makes some sense. This means solving, well, we had one of solving nonlinear systems, but this time it'll be of circles, I guess. Okay, writing and graphing equations of circles. Now, this is a proof in and of itself, sort of. If x and y are any point on the circle, this could be x. Remember, the circle are the points around the rim, not the center, but the points around the rim. Any of these can be any x, y right here, right? You go over x and up y, you go over x and down y. Let it represent any point in the circle with the center at the origin and the radius r. By the Pythagorean theorem, x is like a leg length, y is a leg length, and r is hypotenuse. So x squared plus y squared equals r squared. This is the equation of the circle with the center at the origin. It just looks like that, straight up. It's more basic because there is no displacement of the center anywhere, that it's going to be as basic looking as that. But here's the standard equation of a circle. You get this h and k involved. We've seen h and k before with parabolas. I forget in IM2 what other kinds of equations you did them with, but HK definitely with parabolas. The y equals, we've seen this, and I'm going to bring this up. Y equals a times x minus h quantity squared plus k. Remember, your vertex was at h comma k. Well, look at this. If hk is your center, then x minus h, remember x would be this at this part, and here's h, right? X minus h is the distance right here, and y minus k, this is your y point, this is your k point. Y minus k is the distance here. So x minus h squared plus y minus k squared equals r squared is another equation that we can use here. This relates how far your point is from your center in terms of both r and x, y, and h and k. So this is the standard form equation of the circle. It really is just a form of Pythagorean theorem, and that's kind of the way we'll remember it. So it's at h and k. Now notice that the x minus h is like this x minus h here, kind of as a repeat. But this y minus k, normally back when we would see this plus k and, vertex would be at hk, and we'd say flip the h, keep the k. Now I won't speak too long on this aspect here, but the reason why the k is also flipped in this case is because it's on the same side of the equation as y. Over here, it's not on the same side of the equation as y. Notice that if I subtracted k from both sides, this would say y minus k equals a times x minus h quantity squared. It's a different form of the parabola equation, but when it's on the same side of the equation with y, that's when it's flipped, because it's on opposite sides of the equation. It's not. But here they're on the same side of the equation. And circles, by the way, aren't functions, so we're not going to get y by itself in some scenario. X and y are also on the same side of the equation together. And that's what the equation is going to look like. So we can use this equation to pull out information and then draw a graph. We can also use a graph to pull out information and write an equation. That's going to be a lot of the problems that we do. All right, let's write standard equation of a circle. So, write the standard equation of each circle. This circle that's on the left, it has a radius of 3. The center is at the origin. With the center at the origin, the h and k are 0. This is why you get that x squared plus y squared look like they showed you before. And r squared is 3 squared. So x squared plus y squared equals 3 squared. X squared plus y squared equals 9 is the equation. So we're not solving for anything. We're writing the equation that if you plugged it into a graphing calculator, what would the graph be? And this is the relationship on how x and y relate with that radius. Another one with the center at 0, negative 9, and radius of 4.2. Your h is 0. Your k is negative 9. So minus negative k is a plus 9. Or minus negative 9 is plus 9. And then 4.2 squared apparently is this number. So the equation of your circle would look like this in standard form. Kind of a little different looking, but that's where you can take the graph or information to write an equation. Okay, now let's write the equation of a circle given 2 points, the center and a point on the circle. This is where you need to now find the radius. The radius is the distance between your values. Now they jump straight to distance formula. I use Pythagorean theorem. They just spoke on Pythagorean theorem. I'm surprised they don't do it here. But it's the idea, how far is this, how far is this, this squared plus this squared is that squared. Take the square root. Apparently it's 5. This distance must be 3, and this distance must be 4. Because 3 squared plus 4 squared is 5 squared. Anyway, we get the radius. The center is at this h. Let me write this here. At this h and this k. So given that h and k, we can get the h is negative 1 and k is 3. That's x minus negative 1, or x plus 1 squared, plus y minus 3 squared equals 5 squared. So x plus 1 squared plus y minus 3 quantity squared equals 25 is the equation of that circle. Okay, this time let's graph a circle. Here's what I believe is called the general form of an equation. Not standard form, but general form. The general form basically has every term on one side of the equation, starting with quadratic terms, and then linear terms, and then constant terms set equal to 0. Your goal is to get it in that other form that we had from before, which is the standard form, x plus or minus h squared and y minus k equals r squared. So what we need to do is complete the square. We need to get x's together as a perfect square trinomial, factor down to a squared quantity. Get the y terms as a perfect square trinomial, factor down to a squared quantity. We do completing the square for that. We want to get constants on the other side of the equation. And then in doing so, we're going to get that appearance that we want. So, and I'm getting stuffy again here. So, they first add the 16 over, one of the constants. Now, we're going to get more constants in addition to it, because look how they group the x's together right here. Whoops. And the y's get grouped together right here. And they complete the square. Divide this term by 2 and square it. Divide this term by 2 and square it. And whatever you add to this side, you also add to the other side. So they do completing the square there. This factors to a perfect, this is a perfect square trinomial that factors down. This is a perfect square trinomial that factors down. Again, this is completing the square. I'm not going to reteach it, just kind of show it. And this can help pull out our information that we need. With the equation, we can express that the center, x minus h is 4, y minus negative 2, y minus k, k is negative 2, and 36 is the square of your radius, so square root of that is 6. So that's the information. Did they ask us to graph it? They said then graph the circle. Find the center and then graph it. So with that center, here's how we would graph it. They said use a compass. I probably won't use a compass. I have a circle tool on my thing, but what I'm going to do is this. I'm going to count 6 units right, left, up, and down, and then draw my best circle that I can around that. That's what I'll do for my students, at least in that kind of way. Now, you may say, Mr. Robinson, isn't that 3 units over? These are going by 2s. You can tell here 2, 4, 6, 8. Like that. So that's 2, 4, 6 over. So we can count in the cardinal directions, north, south, east, and west, and then get that out. Let me do some sniffle stuff. Okay. Now I feel like I have to sneeze. Okay. Writing a coordinate proof. Oh, coordinate proofs involving a circle. Prove or disprove that the point root 2 lies on the circle centered at the origin and containing the point 2, 0. So I guess we first come up with an equation that would contain this point here itself. And then we would check and see, well, let's see how they do it. I mean, they can plug in the values, but I figured they would come up with the equation first, then plug this in as x and y. Circle center has the following radius. So they come with a radius of 2. Yes, a point lies in the circle if only the distance from the point of the origin is 2. Okay, so they check and see what the radius of this one would be. If it starts at the origin and at 2, 0 is 2 away, they're trying to see if this one also has the same radius as 2, from root 2 to 0, 0. So that's their version of coordinate proof. That works. What I was thinking of doing was getting the equation of this circle. The equation of this circle would basically be x squared plus y squared equals the radius squared, like that. And then I was going to plug in root 2 for this and root 2 for that, and see that I get 4 on both sides, which you can also do. So there's one version. Maybe I'll follow what they do a little more so. Just check and see if the radius is aligned, which that's technically what we're doing, right? When I come up with the equation of that circle, it's all the same. Because this whole equation is set up on radius talk. Excuse me. Let's solve some real-life problems using graphs of circles. The epicenter of an earthquake is the point on Earth's surface directly above the earthquake's origin. A seismograph can be used to determine the distance to the epicenter of an earthquake. Seismographs are needed in 3 different places to locate an earthquake's epicenter. Use the seismograph readings from locations A, B, and C to find the epicenter of an earthquake. So 7 miles away from A's epicenter, or A's center, I should say, or readings. The epicenter is 4 miles away from B at 4, 6, and 5 miles away from C. So they set all the points equidistant, and then they graph them, and then they see where they intersect. Now the problem with this is we really would have to use a compass if we want to get things perfect, but they all 3 intersect in this one spot like that, and that appears to be at 5, 2. So I hope this is decent enough that we can get something that'll work in our favor. I don't know. I can use my own circle tool, but I don't know what you can use if you don't have a compass. Like, I can grow outward from here like that. I can make perfect circles and stuff, but we'll see how those ones work. That all makes sense. Find out where they all intersect. All right, solving nonlinear systems. So here was the section 4.8 where we did solve ones with parabolas and lines, but now we can do some with circles and lines. So here's a system. Let me circle it. X squared plus y squared equals 1 and y equals x plus 1 over 2. We have to find out where this line intersects with this circle. Now, not literally this circle, but here's the idea. We literally just talked about circles with tangent lines that would intersect once. Circles with secant lines would intersect twice, or maybe they don't intersect at all, right? So those are the different kinds of solutions to the system here, and we have to account for all of them that we have. So what they're going to do is probably a substitution. It looks like it. If y is by itself here, they're going to substitute x plus 1 over 2 for y in the top equation, and you get this. You'd have to expand this out. Well, they multiplied everything by 4. You have to expand this out. This expands out to x squared plus 2x plus 1. 4x squared plus x squared is 5x squared. There's the 2x. And 1 minus 4 is negative 3. And it looks like they then solve using the quadratic formula. I would as well if it's not factorable. It actually is factorable. Let's see, what does this factor to? This factors to 5x plus minus 3 and plus 1. So this would be x equals negative 1 and x equals 3/5 if you get those by themselves. So you can, if it's factorable, we can work that out as well. Looks like they get down to, yes, 3/5 here and negative 1 there. Anyway, so those are x values for the system, and then we have to find the y values for the system. So what do? You substitute both x's into either equation, either this one or that one, to then find your answer. Maybe this one's preferred. It depends on fraction bits, but they did the fraction one. You substitute into either, and you get your values of 4/5 for y when x is 3/5, and then 0 for y when x is negative 1. Those are your two solutions. So that's where, and they're showing you the graph. It crosses like a secant line. So this is where they actually intersect with the circle as a system. All right. I imagine solving for system stuff's going to take a little bit longer in general, so maybe this won't be uber quick. Okay, let's take a look at the vocabulary and core concept check for us. What is the standard equation of a circle? I don't know if they're asking us to define it or the formula, but here is the formula itself. It's a formula that is proved by Pythagorean theorem to express the distances of any point on the circle from the center given the radius. Like that. Explain why knowing the location of the center and one point on a circle is enough to graph the circle. Well, in order to graph the circle, you would need the center and the radius. in order to graph the circle, you would need the center, which we have, and the radius, which we can find using the distance formula. I'm going to appease them by saying distance formula. I would use Pythagorean theorem with a physical right triangle, or at least the idea of it. I could use distance formula, but either or. All you need are center and radius to graph everything. That's all. You could also, maybe they're saying this because they did say use a compass on the other one. You could just use, they just said graph the circle, right? You could just also use a compass and plot it on that point. Let's like imagine that you had, I know I have examples right here. I'm just going to kind of like fit one right here. Let's say this was your center and this is the point on the circle. I could literally use a compass. I'm not going to write it, but just explain it. I could use this guy right here, stretch this out to that width, and go, okay, if that's the radius, I'll fix it to that distance, and then let's just go ahead and draw a circle around it. Boom. So you could just use that information as well. The way I'm going to use the radius is count up, down, left, and right a certain amount from there, and then just go to work on it. So guys, let's get ready for the problem set, shall we? We are going to look at problem numbers 3 through 67. There are times when we're probably going to have to construct graphs, and I'll use kind of graph paper stuff for that. So in exercises 3 through 8, find the center and radius of the circle. Hold on, I just changed the sizing of something here. Center and radius of the circle. So on number 3, I'll keep the graph, the drawing the way it is. Notice that this one's going by 2's, by the way. The center is at 0, 0. That's the origin. And the radius is 2, 4. It's from the center to any of these endpoints there. I'm counting this way, 2, 4 from the center. That's an example of it. So these should go pretty quick as an overall. Number 4, this center is also at the origin. So center is at 0, 0. And this radius, these are going by 1's this time. That's going 1, 2, 3. Radius is 3. Number 5, the center, this one's kind of an interesting, I think you can tell where the center is like that, but if it's hard to figure out, what I would do is find any ultimate endpoints as far left and right as possible and count half that distance. If this whole distance is 4, half the distance is 2, which is the radius, by the way. Oh, these are going by 3's. So instead of going 12 across, half that distance is 6 across, 2 increments. And then you find the center there. So the center itself is actually, it's not at negative 1, 1, it's at negative 3, 3. If you look at the scales, negative 3, 3, and the radius is 2 of those increments of 3, which is 6. Number 6, now I have to check scales each time. I have to be very aware because these also go by 3's. Number 6, that center, hopefully you can tell, is right in that middle part right there. And then 1 increment away, which is 3 units away, is the radius. So your radius is 3. So the center is at 6, negative 6. And the radius in this one is 3. Radius is a distance. Distance is always positive. Doesn't matter which direction you're looking at. Number 7, suddenly they're giving you some actual endpoints with values. Let's work off of those. Notice that negative 0.5 is the same x for both of these because these are directly above and below each other. This is 2.5 and negative 1.5. I mean, we could do a counting version of this. We could also kind of work off midpoints. The midpoint between these two, if I drew a diameter, can also help assist. And midpoint is averaging your values. And I don't believe the book ever fell shy of actually expressing midpoints. We did a lot of them, I think, in chapter 6 when we talked about perpendicular bisectors. So as far as midpoint goes, the center is going to be the midpoint of the x values, which is negative 0.5. I'm just going to leave it like that. And the y values, the midpoint of these, we got to average this. 2.5 plus negative 1.5 all over 2. So that'll be at negative 0.5 comma. That's 1 over 2. So that's 0.5. So that's what this point is right here. And that is half the distance between 2.5 and negative 1.5. The distance between 2.5 and negative 1.5 is 4. And half of 4 is 2. And 2 away from 2.5 is 0.5. The radius. I just said half of 4 is 2. The radius is 2. So there's that distance, right? Once you determine the diameter, take half of it. Or once you determine the center, you can count that out in that length. So that's number 7. Number 8's more of the same, just like number 7, only now we are horizontally across and dealing with fractions. So on number 8, when it comes to the center, notice the x values are the ones that change. We got to take negative 5/3 plus 7/3 and divide that by 2. Kind of a weird look. And then 4/3 will be the y value of this one. How do you divide a fraction by a fraction? We got negative 5/3 plus 7/3. That's 2/3. 2/3 divided by 2. What the heck? Well, what happens here, 2/3 divided by 2 is 2/3 times 1/2. These twos can cancel, if you will, and you get 1/3. So the center is going to be 1/3 for x and the 4/3 for y that was there. So it's probably, if this is 1, 2, etc., 1/3 is probably a little bit like that. And then there's the 4/3 like that. So just kind of understanding that's the center. Now the radius would be like how far from these things? From 1/3 to 7/3. How far is that? Well, 6/3. Excuse me, that's the answer. 7/3 minus 1/3 is 6/3, which is 2. So r is 2. 2 is your radius on that guy. I subtracted the distances there. Okay. Let's go to numbers 9 through 20, where we write the standard equation of the circle. So what you do is you take the graph, you pull out information from that graph, and you write the equation based on that. So in this first one, the center, once again, just pull out the information. The center's at 0, 0. The radius is 2. So this is your h and k. This is your r. So your equation will be x minus 0 quantity squared plus y minus 0 quantity squared equals r squared, like that. X minus 0 is x, so you're left with x squared here. Y minus 0 is y, so you're left with y squared, and 2 squared is 4. And that's the standard equation of the circle on number 9. Number 10 looks to go by 2's. So although the center's at the origin, and they showed you the standard form would just be an x squared plus y squared, so I'm going to leave it like that. X squared equals boom. That'll be 2, 4, 6 as your radius, so 6 squared is what goes here. And you want x squared plus y squared equals 36. So always try and simplify what you have. Not try to, always simplify what you have when they're asking for the equation like that. Now number 11 has a different center. Let's pull out what it is. So on number 11, the center looks to be this guy. The scale looks to go by 3's as well. So the center is at -3, -3. The radius is 369. So as far as an equation goes, let me write the very raw form to begin with. This would be x minus -3 quantity squared, because this is my first time doing it, plus y minus -3 quantity squared equals 9 squared. X minus -3 is x plus 3. Y minus -3 is y plus 3. 9 squared is 81. So there's the equation. That's what it will look like. From here on out, anytime a center is negatives like those ones, I'll be just putting a plus instead of having that part. Number 12 will not be one of those cases because this center is in the first quadrant. Everything's positive, and hopefully you're good on this guy being the center. These go by 3's. This is 6, 3. So with a center of 6, 3, we're going to have x minus 6 quantity squared plus y minus 3 quantity squared. Now this will equal the radius here, which is also 9. So 9 squared we saw last time was 81, and I'll just go ahead and leave it like that. That is the answer to number 12. Scared to see what's on the other side for all the way up to number 20. Oh, they do 2 more graphs and then 6 ones that are not graphs. So number 13, we have here, look what we have here, a center. These are going by 4's now. You can see that's an 8. So that center is at 4, 0. And the radius is 4, 8. So that would be x minus 4 quantity squared plus y minus 0 is y, so we'll get y squared, equals 8 squared, and that's 64. Remember, x minus h, flip that sign. Number 14, let's just play with the center and see if we're good on writing the equation straight up from there. The center looks to be at, these are going by 4's again, 0, -4 this time. So the h is 0, so this time this will be x squared, plus, and then it's a -4, so we're going to put y plus 4 quantity squared, and then this is 4, 8, 12. 12 squared is 144. Generally, I'd like to write work for those kinds of things, but I think once we've done a couple like that, it works out. 15 through 20 are ideally easier than 9 through 14, because 15 through 20, you have the information. The way I like to see these problems is information is the middleman between writing an equation and we're making a graph. If I want to go from graph to equation, I'd like to state what the information is first. And if I want to draw a graph from the equation, I'd like to state what the information is first. So this is the information. This is the middleman to either make a graph quickly or write an equation quickly. A center at 0, 0. This time, because it's actually written, I feel compelled to copy these things. The radius is 7. So this is going to be x minus 0 squared plus y minus 0 squared equals 7 squared. That's number 15. Number 16, we have a center at 4, 1. That's our HK. And radius 5. So center at 4, 1. And radius of 5. This is x minus 4 quantity squared plus y minus 1 quantity squared equals 5 squared. Again, because now we're at the information part, which should be significantly easier, I'm not going to show any work unless I feel it's like necessitated to work out. 17, we have a center, an h of negative 3, and a k of 4, and an r of 1. X minus negative 3 is x plus 3. Y minus 4 comes next, that's also squared, equals 1 squared. And 1 squared is just 1. This is a unit circle that is off the origin. Number 18, the center is at 3, negative 5. The radius is 7. Not a lot of problems for the same bit. 3, negative 5. None of these are really, it looks like radii later are going to be decimals, but that's it. Radius is 7. This is x minus 3 quantity squared. Plus, and then y plus 5 quantity squared. That was a minus 5 there. And this equals 7 squared, which is 49. I think we had one of those before. And then two more in this set, numbers 19 and 20. We have negative 2, negative 6 as our HK. So this will be, boom. And then radius is 1.1. I should know that squared. This is going to be x plus 2 quantity squared plus y plus 6 quantity squared equals 1.21 squared should be, 1.1 squared should be 1.21. That is, again, 1.1 squared. And then number 20, 32 squared, 10.24? I think so. Center is at negative 10, negative 8. Radius is 3.2. So both these will be added, x plus 10 quantity squared plus y plus 8 quantity squared equals 10.24, I believe. I don't want that to be wrong. I don't think it is. No, it's not, because it's 2 to the 5th times 2 to the 5th. We haven't had to draw our own graphs yet. I think we're probably about to, but no, not yet. But yeah, I'll have graph paper attached is what I was going to say. That I didn't have to whip out my axes yet. So we'll see when we need to. In exercises 21 to 26, use the given information to write the standard equation of the circle. Thought we just, oh, okay, this is different stuff. So the center is at 0, 0, and then we have a point at 0, 6. Now, our goal for this is our h and k. For the standard form, we need r. So r is the distance from the center to the point. In reality, this is here, this is here, this is 6 away. That's your r for this case. So radius is 6. I don't have to use Pythagorean theorem for something that's straight above or right, left, or down. H and k are 0, so this will be x squared plus y squared equals, and then r squared is 36. Number 22, I'm sure we're going to get one. Not this one, but I'm sure we're going to get some at some point where we kind of have to do more Pythagorean theorem, distance formula, something like that. So number 22, the center is at 1, 2, and it crosses through a point at 4, 2. Now, how far is 1, 2 from 4, 2? The heights are the same. From 1 to 4 is a distance of 3, so your radius is 3. With hk being 1 and 2, this will be x minus 1 squared plus y minus 2 squared equals r squared. 3 squared is 9. Still information. We just got to pull it out. Number 23. The center is at 7, negative 9, and a point on the circle is 3, negative 6. This is where your distance formula, Pythagorean theorem stuff will come into play, because these are neither immediately left, right, up, or down. But the point is at 3, negative 6. So my general one I like to do is Pythagorean theorem. 7, negative 9. Oh, I guess it's a little lower for both of these. 7, negative 9 is, say, down here. This can be your center. And then 3, negative 6 can be the point that's right there, and we're going around that. So what is the distance from 3, -6, 7? What's the distance from, this is the Pythagorean theorem part, what's the distance from 7 to 3? That distance is 4, that's x. From -9 to -6, that distance is 3, that's y. So 3 squared plus 4 squared equals 5 squared. That's a Pythagorean triple, so your radius is 5 in this case. No, I did not show work. I will not show work for Pythagorean triples. They are things that we had covered in the past. You can try it with Pythagorean theorem, and that's what you'll get. This is your h, k, and r, so we can say x minus 7 quantity squared plus y plus 9 quantity squared equals r squared of 25. Now, I did not require this visual. I'm giving you the understanding of the Pythagorean theorem that is set up, so for future problems, I can probably just say them out loud. If I feel like I should use distance formula, I will. Remember, distance formula is just a form of Pythagorean theorem, getting the same values in a different light. Okay, the radius here, you know, it's the r squared thing. We can do a squared plus b squared equals c squared. When I point to a squared here, I'm saying the distance from -4 to -10. So that is 6. 6 squared plus, and from 3 to -5, that distance is 8. And this will equal our r squared. This case, r will be 10. This is again another 3, 4, 5 Pythagorean triple where everything's doubled to 6, 8, 10. So your radius is 10. The equation is x plus 4 quantity squared right here plus y minus 3 quantity squared equals r squared. We still have to square the r. Square 10, we get 100. Number 25, the center is at the origin. A point on the circle is 3, -7. This really doesn't need distance formula. It needs Pythagorean theorem still. But it doesn't really need distance formula in the sense that, what's the distance from 3 to 0? What's the distance from -7 to 0, right? So those are 3 and 7. So we can do r is 3 squared. R squared is 3 squared plus 7 squared. This one needs, it's not a Pythagorean triple, so this one needs a little more work. 9 plus 49, which is 58. So r is the square root of 58, which cannot be simplified. So we're going to leave it like that. Now, here's the thing. Honestly, here's the thing. We don't actually need r. We're writing the equation. We actually just need r squared. Simplifying this wouldn't have been really of much benefit to me. R squared is actually the value that I'm looking for because the equation is x minus h squared plus y minus k squared equals r squared. So I'll stop short, unless they're asking me to graph it or find the radius, I'll actually stop short on taking the square root. It's actually not even used. Now, on the last problem, because there was a Pythagorean triple, I wanted to clearly state the 10, square it thereafter. Maybe it's a good reminder that you still have to square anyway. Number 26. The center is -1, -3, and a point on the circle is -5, 8. So from -1 to -5, that distance is 4. From -3 to 8, that distance is 3 plus 8, 11. And we can find r squared from there. Once again, not a Pythagorean triple. Here's the thing. Once again, I only need r squared. 137. I do not need the square root of it. My equation will ask me at the r squared. So I can use x plus 1 quantity squared plus y plus 3 quantity squared equals r squared. Remember, you don't have to square that value. It's already squared. 37. I think that might be a prime number as well. Okay, number 27. Describe and correct the error in writing the standard equation of the circle. I'm guessing they didn't square their r value. Let's see. Or they didn't flip a sign. 27. So the standard equation of the circle of -3. Oh, they didn't. Yeah, they didn't flip the signs. -3, -5 has the x minus 3 and y minus 5. The radius is 3. The r squared is 9. That part's correct. The problem is the signs got to flip inside the equation. The h and k appear as opposite signs in the equation. Now, if you still don't know why that is as an in general thing, it's all about finding the distance from your point to the center. X minus h is how far away your point is from the center in the x direction. Y minus k is how far away it is from there. That's why they're flipped. It's not just like a magic step like, hey guys, in math we flip things. No, there's a little more to it. They have opposite signs in the equation. They should be x plus 3 quantity squared plus y plus 5 quantity squared equals 3 squared, which is 9. All right, number 28. Describe and correct the error in writing the standard equation of the circle that's graphed. Maybe a scale issue? They go from 3, -6 down to 3, -11. That radius is 5, so we got to square that. They didn't square it. The x minus 3 and y plus 6 are good as far as things that are squared and done. R equals 5. So we got to square that. They did not square the radius in the equation. For Pythagorean theorem. So it should be x minus 3 quantity squared plus y plus 6 quantity squared equals 5 squared, 25. Okay. Yeah. Let's move forward. These are the general forms, or at least we're going to get to them. Find the center and radius and then graph the circle. So this is where graphs will be had. This is where we have 29 to 38. That's, 10 problems? Okay. So I was going to say that with one single printing of one of my graph things, my graph paper has, I think, 12 graphs on each. So you should be able to fit all of these on there if these are kind of the only ones that you do. So number 29. Let's drag our number marker down. X squared plus y squared equals 49. Now, I've mentioned, what do they say? Find the center and radius. Okay, well, we're going to do that anyway. I was going to mention that if I want to graph, I want to pull the information out. What's the center? What's the radius? We've seen a couple x squareds and y squareds here before. That's x minus 0. So your h is 0 for your center. Your k is also 0. Now, your r squared is 49. Take the square root, you get r is 7. Plus or minus 7, but we're not dealing with positive, negative center, negative radii, negative lengths. No. So here's how I'm going to graph it. I'm not going to use like a compass, but I'm going to plot this at the origin, 0, 0. Remember, the origin is not a part of the center is not a part of your graph, but it will help describe where the points on our graph go. I'm going to go all the way as far right 7 units as I can. I'm going to go 7 units up, 7 units left, and 7 units down. For this one graph, I'll do the sketch thing around it. For other ones, I'll probably use the circle tool. Just want to say, make sure it looks kind of as good as you can. Not so lemon-like. But, yeah, some students tend to do, and I'll bring this back, but what some students tend to do is more like this. Not quite a circle, right? So, much more arc to it, please. Fatten that thing out. Sorry if I missed. I totally did. There we go. Okay, so that's number 21. Number 22. X squared plus y squared equals 64. This is so very similar to the last one. Center's at the origin. Center's at the origin. This time, the radius is 8. Square root of 64. So very, very similar-esque looking graph. Shrink it a little bit. Center's at 0, 0. Radius is 8. If I go 8 outward like that, I can also go up, left, and down. Now, I will use the circle tool this time. Probably in future times, I might look to do it as well. If it saves me time. You might have to make the drawing as you do, but there's the graph, the circle. Perfect as it gets. Number 23. X plus 5 quantity squared plus y minus 3 quantity squared equals 9. Now, they do ask you to pull out the information anyway. So, for x plus 5 quantity squared and being x minus h, the h value should be negative 5. For y minus 3 quantity squared being the y minus k portion of this, the k value should be positive 3. So your center's at negative 5, positive 3. And that's not a plus, that should be an equals. Your r squared is going to be the square root of 9. Excuse me, the r squared is going to be 9, so r is going to be the square root of 9, which is 3. So, when it comes to graphing this thing, we're going to be at negative 5, 3. Radius of 3. So I should be able to go 3 up, down, left, or right. Let's just kind of go 3 down to that 3 downward like that. And it's tangent to the x-axis. I don't know if that's a phrase that they're going to use, but it's touching the x-axis tangentially right there. Number 32. Wait, I said 23, 22. What was I doing? 21, 28. What happened? I'm so sorry when I called the numbers out. This must be a 29. This must be a 30. You're like, what are you doing? Hopefully the timestamps align just fine. This is 31 and 32 cometh. So number 32, x minus 6 quantity squared plus y plus 2 quantity squared equals 36. Y minus 6 quantity squared. Sorry, that's just the x. The y plus 2 quantity squared. That's going to be a negative 2. Like that. That's the center. 36. The radius, I didn't write these. The center, it really helps to write, is at 6, negative 2, and the radius, the square root of 36 is 6. Now, the one hiccup for my thing is if I go right, I run off the page, probably around there. I'm not sure. But the good news is I can go any other direction, like this one, and kind of get my circle out of that, especially if I use the circle tool. If I went up and down, I could fit it too. But right there, you can see where that goes off the page. You can see I wasn't quite close, being 6 away like that. Kind of like that. Okay, number 33. 33 through 38 are in some general form, maybe not the general form, but they have something where we have to do completing the square somewhere if they're not already perfect squares to begin with. So x squared plus y squared plus 4y equals 32. A lot of this is kind of like slope-intercept form, not this itself being like slope-intercept form, but you treat it like you do slope-intercept form. This isn't your radius until you're truly in standard form, where you have the x minus h squared, that kind of stuff. Now, there's no other x term on this side of the equation or that side. It's just the x squared term. So that'll be all that this one is. The y squared plus 4y, though, can turn into some squared quantity that we want to get to. So it's going to eventually take on this kind of appearance. It has to for a circle to be functioning the way that it does. But what do we have to do there is completing the square. Y squared plus 4y plus blank, some number, equals 32 plus that exact same number. 4 divided by 4 is 2. 2 squared is 4. So 4 is what's going to be added to both of these. And y squared plus 4y plus 4, two numbers that multiply to 4 and add to 4 are 2 and 2. And that's the factorization of that. 32 plus 4 is 36. This is the equation of the circle. You can tell 32 wasn't r squared. It's going to be 36. So this center, and we still have to graph it, the center is going to be at 0, negative 2. Your r value is going to be 6. And then let's sketch that graph from there. So 0, negative 2. And then going up, right, left, down, or down, left, like that. Boom. Okay. Cool. All right, number 34. X squared plus y squared plus 4y equals 30. I did the wrong problem. All right, so this was 30. Okay, sorry, guys. Yeah, hopefully this timestamp stuff will work itself out. Number 34 was number 33 is right there. Hopefully this will find itself out. That's 34. Sorry about that. 33. You're going to say, Mr. Robinson, you missed a problem. Well, I got back to it. Number 33. I was going to say, it's the same thing that you do. It's the same problem. Okay, x squared plus y squared minus 6x equals 7. Now, the constant's already on the other side of the equation. This time there are multiple terms with x and only a single term with y. So I want to put x squared minus 6x next to each other and complete the square right here. Make a perfect square trinomial. And whatever I add on this side, I add on this side as well. Notice that the y squared is by itself, so I'll keep that as its own perfect square set. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So 9 will be added to both. Negative 3 is the number that exists in the factoring of this like that. And 7 plus 9 is 16. This is the standard form equation of the circle. So we are at 3, 0 for our center and a radius of 4. So 3, 0, radius of 4. So it should look right there, 3, 0. 4 is 4 in any direction. 1, 2, 3, 4. And that should be your graph there. I mean, do you need to keep the center? I Probably not. It's probably one of those things where an answer key wouldn't have it. And maybe some teachers would say, yeah, go without it. You don't want to be confused and think it's actually a point that's on your graph. All right, we did 34. Let's go to 35. Now in 35, both numbers have, or both variables have their own second terms to them. So both probably need some form of completing the square. So x squared plus y squared minus 8x minus 2y equals negative 16. Let's arrange the x terms together to find out what to complete the square with on those. Then let's complete the square on the y terms. And negative 16 will add both of those numbers. I'll put plus blank, plus blank. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So we're going to add 16 and 1 to both of these. Now this started off as a negative 16 right here. So we're going to do negative 16 plus 16, which is 0. And 0 plus 1 is 1. This factors down to x minus 4 quantity squared. And this factors down to y minus 1 quantity squared. So until we're in standard form, we don't truly know what something is in any sense until we've kind of gotten it in that standard form. So this is a... we're supposed to write the information, find the center and radius. So the center, I was going to say vertex. The center is at 4, 1. The radius is the square root of 1, which is 1. So let's go ahead and graph that. Center's at 4, 1. And the radius of 1. This can, I'm not going to use the circle tool this time. Let's keep it nice and small. And apparently this other equation also showed us that, but that would take a lot to plug in and get some values out for. So I'm not going to do that. Number 36. Let's change the problem. X squared plus y squared plus 4x plus 12y equals negative 15. The x squared plus 4x will go together. We're going to add a 4 there. I think we've already seen that. And then y squared plus 12y, 12 over 2 is 6. 6 squared is 36. That completes the square. Negative 15 will add 4 and 36 to it. Whoops. Oh, yeah, let's put little things. 4 and 36. Like, this one gets out of there. X squared plus 4x plus 4 factors down to x plus 2 quantity squared. Y squared plus 12y plus 36 factors down to y plus 6 quantity squared. Negative 15 plus 4 is negative 11. And 36 is 25. So 25. There's the equation. The center is at negative 2, negative 6. And the radius is the square root of 25, which is 5. So there's the equation. There's the information. Here comes the graph, which will bottom out because we'll go from negative 6 and then 5 downward. So negative 2, negative 6 is a point, is the center. 5, any which way, 1, 2, 3, 4, 5 should be enough there for my compass, for my circle tool, like that. There's the one that goes downward like that. Okay, numbers 37 and 38, more of the same on completing the square, only this time set equal to 0. I'd say this is the true general form. And honestly, there's nothing I do out of general form for myself personally. I don't graph out of it. I don't kind of solve equations out of it. It's more just a version of the graph that you can use. All right, number 37, we have x squared plus y squared plus 8x minus 4y plus 4 equals 0. So my first step I'm going to do is move, well, it's kind of interesting because this plus 4 will help with the perfect square trinomial of y squared, but it's maybe something you don't recognize, and I don't expect you to. So we'll put the x's together in anticipation of completing the square. I'll put the y's together in anticipation of completing this square. But over here, I'm going to have subtracted the 4, and let's add 16 and 4. So you can see where the 4s kind of just worked against each other there, but it's not that slow to do. It's pretty fast to do. So this factors to x plus 4 quantity squared for the x's, y minus 2 quantity squared for y's factorization. Negative 4 plus 4 is 0, plus 16 is 16. They're giving us nice clean numbers to begin with here. So the center is at negative 4, 2, and the radius is 4. So as far as a graph goes, at negative 4, 2, we are right here. The radius of 4 is up 1, 2, 3, 4 like that, and down left and right. That should be enough for what we do. That's how we do. It looks like I'm always overscaling down on the other side a little bit, so I can try and shrink, but it's not going to put everything perfect. That's okay. All right, number 38, last one in this set. I'm kind of hoping for more of these if they're short enough. These ones probably average 2 to 3 minutes each. X squared plus y squared plus 12x minus 8y plus 16 equals 0. Clump the x's together. X squared plus 2x plus, divided by 2 and square it is 1. Y squared, let's come up with that one as we subtract 16 over. This is 16. We've kind of seen that number before. So we're going to add 16 and 1. Negative 16 plus 16 is 0, plus 1 is 1. That's the right side. The left side, this factors x plus 1 quantity squared, plus y minus 4 quantity squared. And that equals 1 squared, which is 1. The center is at negative 1, 4. And the radius is 1, the square root of 1. Numbers 39 to 44, we are going to approve or disprove the statement. And I hope that these kind of work in the way that they say see example 4, and the textbook kind of did something on them. So let's see how they work it out. The point 2, 3 lies on the circle centered at the origin with radius 8. Here's actually what I said I would do their thing. I think I'm going to kind of go off mine. They're both the same thing. Mine goes straight into the equation. Theirs goes more into like distance stuff. It says the point lies on the circle centered at the origin with radius 8. So the equation we're talking about is this one. X squared plus y squared equals 8 squared, 64. We want to see if we substitute 2 for x and 3 for y, if we get an equation that says 64 equals 64. The whole idea of this equation, again, is this is the radius squared. This is the a squared plus b squared that gives us the c squared in the thing. The only way that this works is if this is a right triangle and if Pythagorean theorem works and that kind of stuff. So, does 2 squared plus 3 squared equal 64? No. This will be 4 plus 9. And that'll be 13. 13 doesn't equal 64. So, does 2, 3 lie on the circle with a radius of 8? Heck no. They said prove or disprove. I'm just going to kind of use the same thing each time if this is all they're asking. So the point 4, comma, root 5 lies in the circle centered at the origin with radius 3. So this one, centered at the origin, is x squared plus y squared. And then root 3 squared is 3. I'm sorry, 3 squared is 9. I thought they said root 3. They said root 5. So 3 squared is 9. Let's plug in 4 and root 5. So is 4 squared plus root 5 squared equal to 9? Not quite. 4 squared is 16. Root 5 squared is 5. But this was not still a 4 anymore. 16 plus 5 is 21. 21 is not equal to 9. Once again, a no. Unless I'm doing something way wrong, the first two are no. Number 41. The point root 6, comma 2 lies on a circle centered at the origin and containing the point 3, negative 1. So this time you have to figure out what that other point thing is. And I think this is where the book probably did a little bit more. They kind of used a distance formula thing. I will find the radius, or at least the r squared, and see if that kind of works out for you enough. So as far as our r value goes, excuse me, r squared is a squared plus b squared. Why is it 3 and negative 1? Well, it doesn't have to be negative, but why are they 3 and 1? Because the center's at the origin. So the distance in the x direction is 3, the distance in the y direction is negative 1. So this is r squared equals 9 plus 1, and r squared is 10. So you could take the square root of both sides, but I could also leave it as r squared if that kind of helps me as well. I have two options here. I can either work out, they're going to give you the same bit when it comes to option. I can do the exact same thing here and just say, is this the same R that we get? Or I can use the equation and plug those in, but take a look. The equation is Pythagorean theorem in and of itself. R squared is 10. So let's substitute root 6 for x and 2 for y. Root 6 squared plus, I think this one works, plus 2 squared equals 10. Don't change the 10. Root 6 squared is 6. 2 squared is 4. 6 plus 4 equals 10. Yes, indeed. 10 equals 10. So, prove or disprove the statement that this lies on the circle. The other ones I said no. Here I'll just say yes. Yes or true. Yes, it does. Disproven a lot of folk leading up to that. Number 42. The point root 7 comma 5 lies on the circle centered at the origin containing the point 5,2. So let's find the 5,2 bit. R squared is 5 squared plus 2 squared. So that's 25 plus 4, which is 29. If R squared is 29 and we contain the, we're trying to see if root 7 comma 5 goes there. This equation for this one is x squared plus y squared equals 29. Remember, the center is at the origin. So there's no change in shift. There's no x minus h or y minus k. That's not 0. So let's substitute root 7 for x. This is root, not negative. Root 7 comma 5. And then 5 for y. Root 7 is 7. 5 squared is 25. So this will be 32. So it does not work. Big fat no. This was in question. Whoops, that's not in question. That's the formula. This was in question here. This was in question there. All right, number 43. I think 2 more for the 44. Number 43. Like, all right, number 43. Number 43. The point 44 lies on the circle centered at 1, 0 and containing the point 5, negative 3. This time the center is not at the origin. When it comes to your distance stuff, once again, you got to find the distances between y's and x's. I've been big on just using a Pythagorean theorem form. I think the next one, I don't know. I might be good on the next one too. So with this one, the point 44 like that. Okay, so 1, 0 is your center. Now the r squared is, it says containing the point 5, negative 3. This isn't just your x thing. You got to take the difference from your x to your center. So that's 4. 4 squared plus, and then from 0 to negative 3, that distance is 3. So 4 squared plus 3 squared. All right. So r squared is 25, so the radius there would be 5. Let's see. Let's write the equation. The equation is going to be x minus 1. The center is at 1, 0. Squared plus y squared equals r squared, 25. Let's see if 4, 4 works into here. Substitute 4 for x. I think it will. 4 minus 1 is 3. And 3 squared is 16. 9. 4 squared is 16. So you get 25 equals 25. So yes. Yes, we proved, I guess, that thing works. So in question, and all good. All right, that's number 43. Last one on this set is number 44. They have a 2.4 comma 4 set up there. And then here we have these points that are a little farther out. But 44. Your r squared is x squared from negative 3 to negative 11 is 8. Plus y squared, 2 to 8 is 6. So 64 plus 36 is 100. Which 10. 10's the radius there. 2.4 comma 4, very particular, something which I don't think will work because I don't think it's going to be landing on an integer. But let's see how close we get. 2.4 for x. Oh, I'm sorry though. I don't think it's going to change. But the center is at negative 3, 2. So the equation is going to be x plus 3 quantity squared plus y minus 2 quantity squared equals 100. So let's figure out how far off these ones are. 2.4 is how far away from negative 3. That's 5.4 away. That's why when we substitute this in here, we're going to get 2.4 plus 3. And then from 4 to 2, that'll be 4 minus 2. Plug that in, right? So yeah, I kind of use the equation bits a little more. So 5.4 squared. I thought I was going to have to do 2.4 squared because I know that one. Plus 2 squared equals 100. So this is something plus 4. So 5.4, let's see. 29.16. So 9.16 plus that equals 100. Not even close. This is 33.16. Doesn't equal 100. It doesn't. It does not. It doesn't. It doesn't. There's that one, and this answer is a no. A lot more no's than yeses than I actually expected. Okay, let's move forward. Let's go to number 45, modeling with mathematics. A city's commuter system has 3 zones. Zone 1 serves people living within 3 miles of the city center. Zone 2 serves those between 3 and 7 miles from the center. Zone 3 serves those over 7 miles from the center. Pretty far. Graph the situation on a coordinate plane where each unit corresponds to 1 mile. Locate the city's center at the origin. So I have to take that. So part A, graph them. Graph decision on coordinate plane. So here's our center. Zone 1, people living within 3 miles. So up 3, right 3, down 3, left 3, kind of stuff like that. So here's zone 1. I'll call it Z1. Z1. Z2. Zone 2 is between 3 and 7 miles. 4, 5, 6, 7. And then zone 3 is over 7 miles. So it doesn't really have an ending part. It just is zone 3. So there's zone 1, there's zone 2, and zone 3. Pretty much everything else. Determine which zone serves people whose homes are represented by these points here. So 3, 4 over 3 up 1, 2, 3, 4 is zone 2. So at 3, 4 is zone 2. 6, 5 is at 6, 5. Looks like it's outside right there, so that's going to be zone 3. I think most of them will be zone 2. 1, 2. 1, 2 is inside zone 1. And then, sorry if you couldn't see that. And then 0, 3 on the bubble of zone 1, but it's within, let's see. It says, one says within 3 miles, someone says between 3 and 7 miles. I assume this is part of zone 1. That's a toughie. I assume it's part of zone 1. And then 1, 6. At 1, 6, we have zone 2. Only a couple, I think at least one of them was actually on the circle. The other ones didn't really seem to be. So on the first one, that's 5 points. On the first one with 3, 4, never mind. Yeah, that's exactly what I wanted. All right, there's part B. I'm going to pause for a little bit. I got to take care of something, and then I'll be kind of back with this. Okay. And we're back. Okay. All right. Number 46. What was this? This modeling with okay. Telecommunication towers can be used to transmit cellular phone calls. A graph with units measured in kilometers shows towers at points 0, 0, 0, 5, and 6, 3. These towers have a range of about 3 kilometers. Shows towers at these points. Sketch a graph and locate the towers. Okay, I gotcha. So 46. Are there any locations? All right, so this is where I really do want to use that circle tool. I don't want anything to not be drawn to scale, but I think will be good. They call them towers A, B, and C or anything. They say city A, B, and C. A graph with units. So we got 0, 0. And a radius of 3 going out from that one. Still won't be, I'm still not doing it perfect. Okay, the next one is at 0, 5, also with a radius of 3. So this one will be different colors. Let's just do the same color. So also with a radius of 1, 2, 3. We can really copy and paste the sizes, but it's not that long to do. I still have to find that center. The center of the next one is 6, 3. So the radius is still 3. 1, 2, 3. A graph with units measured in kilometers shows towers at points here have a range of about 3. Sketch graph. Are there any locations that may receive calls from more than one tower? Explain your reasoning. Yes. From those first 2 sets of towers or points of intersection there and there. Now, they didn't say what the points were. Maybe it's that like 1.5 comma something, but I don't think so, right? That's where you can solve the system algebraically to figure that out. So these 2 points, I'm not going to say more than that. That's just part A. Boom. It's where they intersect. Part B, the center of city A is located at -2, 2.5. -2, 2.5. Oh, that could be that one right here. Wait a minute. Maybe that's, I guess. I don't know if that's quite the point of intersection. Maybe that's a little too close to it. So I can't tell if those are supposed to be them or not. I don't think so. Now it's a sneeze. Excuse me. Center B is at 5, 4. 5, 1, 2, 3, 4. So here's center. Oh. Do I have to? I still need the things, right? So -2, 2.5 is around there. I'm going to call that center A. Center B is at 5, 4. City B. Each city has a radius of 1.5 kilometers. Which city seems to have better cell phone coverage? Oh, okay. I thought we'd see where it intersected or something. So 1.5 kilometers. Cell, city B. Boom. City A. Boom. Kind of like that. A seems to have coverage dropout right here. So city B seems to have more. B is more. Let's type it. I was like, I forgot what they called it, and I looked. So, all right, there's part B. Okay, let's go to exercises 47 to 56. That one sneeze really took a lot of my throat. Oh, this is the solving the systems. The non-linear systems. All the bottom ones are y equals, so it makes sense to always do substitution for these with a thing for y. So on 47, we get x squared plus y squared equals 4, and y equals 1. 1 will substitute in for y. Pretty straightforward process. So x squared plus y, 1 squared. This 1 will go in for y, equals 4. That's x squared plus 1. And x squared is 3. Now x is plus or minus root 3. And I do need both. This isn't an x like a distance like radius is. We do need both of these. We have to substitute positive root 3 and negative root 3 into an equation to get for y. But we already know that y is 1. So we're good on that part. So the final answer set is root 3 comma 1 and negative root 3 comma 1. Oh, that's an alarm for something. Hold on. Give me 1 second. Awkward. Okay, I'm back. All right. So, there it is. Number 48. The first couple are just with the value. So, the y equals -5 means that'll be the solution to the system there. Now, they didn't ask to graph them, but that's a horizontal line at 1, so the only way that it's possible is for that to be like that. So, x squared plus y squared equals 1. And y equals -5 is my system. Let's substitute -5 into that equation. And we will get 25. X squared equals -25. Excuse me, negative 24. Can't take the square root of a negative. So there's no real solutions here. No real solutions to the system. I think that's how you'd say it, or no solutions or whatever. See, this graph would look like this. Y equals -5 is this line right here at -5. X squared plus y squared equals 1, and I didn't even recognize this. It's a circle with a center of a circle with a radius of 1. They just don't intersect. There are no values that they intersect at. So I guess -5 is not the point of intersection thing there. All right, number 49. This time we'll have y equals equate, now the graphs, if you look linearly, will do more of this kind of thing. So x squared plus y squared equals 64. Looks like your centers are at the origin here quite often for these ones. And y equals x minus 10. Now x minus 10 will substitute for y in this part of this equation. So we'll have x squared plus, and this will say x minus 10 quantity squared equals 64. We have to expand the x minus 10 squared appropriately. X squared minus 20x plus 100. This is a quadratic to solve. X squared plus x squared is 2x squared. Let's subtract the 64 over here to get 36. I want to imagine they're going to do more rational kinds of solutions first. Divide everything by 2 as I can. Why is that so hard for me to figure out? 9 and 2, 10. I don't think that's factorable. So let's make sure everything's right. 64, 36. Not factorable, right? So if not factorable, we'll find the solutions using kind of a different approach with that. I feel like they wouldn't give you one that's like that. Is this factorable and I'm just not seeing something right? 18 is 6 and 3, 9 and 2. So let's actually solve this set differently. Minus 10x. Let's complete the square. We've been talking about that. Complete the square by adding something to both sides of this. That should be a negative 18. Divide by 2 and square it. 25 and 25. So assuming all my math was right, this will be x minus 5 quantity squared equals negative 18 plus 25 is 7. And then we can take the square root of both sides, where we get x minus 5 equals plus or minus square root of 7. So x is 5 plus or minus root 7. That just seems like a lot of stuff to evolve into that answer from the answer that we had before. Number 49. Yeah, so, and by the way, this isn't that final answer set, right? But just the idea is, I feel like that was just a lot to get into for something that was... It's a pretty quick jump from the very basic ones that we have. So those are the x values. 5 plus or minus root 7. So when x is 5 plus root 7, we have to substitute that into y. And this is the easy one to get into. So when x is 5 plus root 7, let's see. Let's write it x equals 5 plus root 7. I forgot how I organized this before. I'll just do it here. X equals 5 plus root 7. The y value, it's x minus 10, right? So 5, x minus 10. 5 plus root 7 minus 10, which is negative 5 plus root 7. And then when x is 5 minus root 7, this will be y is 5 minus root 7 minus 10, which is negative 5 minus root 7. So the two ordered pairs are 5 plus root 7 comma negative 5 plus root 7. And, that's not a plus, that's an and 5 minus root 7 comma negative 5 minus root 7. Quite a bit of information for just that one problem to have there. And we have some more after that. So let's see how many of them do that. Number 50. We have x squared plus y squared equals 2. Not a classic radius case. Maybe more rational things to come. y equals x plus 2. I have no idea because this it's a system. So let's substitute x plus 2 in for y. We get x squared plus x plus 2 quantity squared equals 2. That's x squared plus 4x plus 4. Combine these. Subtract the 2 over. And yeah, this thing looks like it'll actually clean up. If I divide everything by 2, I get x squared plus 2x plus 1 equals 0. This is a perfect squared trinomial where this factors into x plus 1 quantity squared. There's only one solution here, which is x is negative 1. Kind of is an answer twice or whatever. A repeated root, I believe the book would say. But let's substitute that in for y. Y is negative 1 plus 2 for the equation. So that's y equals 1. So the equation, the solution to the system is negative 1, comma 1. Okay, number 51. Number 51. X squared plus y squared equals 16. And y equals x plus 16. Numbers getting a little big. Let's see what we can do with it. We get x squared plus x plus 16 quantity squared equals 16. Or x squared plus, this is x squared plus 32x plus 256. And if you're still not sure how I'm expanding those, I'm squaring the first term, squaring the last term, boom, boom, and doubling the product of 16 and x in that case. Combined, we get 2x squared. All these are going to kind of become this thing where you can like divide it by 2, it seems. Subtract the 16 over, that's negative 240. And I can divide everything by 2. I get x squared plus 16x minus 120. That doesn't look... Oh, actually, it's a minus. 40 and 3, 30 and 4, 20 and 6. Probably factorable. No. I was going to say 15 and 8. 15 times 8 is that, but that's not the number. I don't know for sure, so let's do completing the square. X squared plus 16x plus blank, I'm kind of giving up on it, is 120 plus blank. Divide by 2 and square it. No, this doesn't look like this would have worked. Divide by 2 and square it, so not factorable. So let's work off the non-factoring. This perfect square trinomial factors to x plus 8 quantity squared. 120 plus 64 is 184. So x plus 8 is the square root of 184 plus or minus the square root of 184. So x is negative 8 plus or minus the square root of 184. Now 184 can at least divide by 4, and you get 46. And 46 doesn't seem to have anything else with it. So I guess it's 2 root 46. I guess, is that the number that I'm saying there? So 2 root 40, it seems like a lot there for just that little bit. Are those the answers? Is there something I messed up on? Oh, I'm sorry. I messed something up completely. I'm looking at this stuff and I'm saying 256 minus 16 is positive 240. That's a positive 120. And then if that's the case, then this is a negative 120. Hold on, time out. Let's fix this part. Negative 120 plus 64. I am so sorry about that. I didn't catch that. That is... I don't know. Negative, this part is going to matter, but it's negative 56, I think. Negative 56. So it's at this point we had a no solution. You take the square root of both sides. No real solutions. I was wondering. It was kind of weird. No real solutions there. Can't take a square root of a negative, so I'll just kind of leave it there. That's number 51. Number 52 is this guy. X squared plus y squared equals 9. And y equals x plus 3. This seems prime for something to work. Does it hit tangentially? I don't think so. I think it's going to hit 2 points. Let's see. So x squared plus y squared equals 9. In r squared, if you will. This is x squared plus 6x plus 9. This one, if I subtract the 9s over, either way that I subtract the 9s over, I get 2x squared plus 6x equals 0. I can divide by 2 and get x squared plus 3x equals 0. I mean, at some point, my goal is common factor of x, or the 2x. But I factor an x out, I have x plus 3 equals 0. So using zero product property, x either equals 0 or negative 3. If x equals 0, you substitute 0 for y in here, you get y equals 3. If x is negative 3, you substitute y into there, and negative 3 plus 3 is 0. So your solutions here are 0, 3, and negative 3, 0. Yes, this makes sense. This graph set, it's like here's the circle, and it kind of crosses through there and there as it goes along. Those are the 2 points that it's going to hit. 0, 3, and negative 3, 0. All right, number 53 and 54. We have fraction talk going. Center's still at the origin for these other guys. So 53, x squared plus y squared equals 1. And this is y equals negative x plus 1 over 2. All over 2. Okay, so let's substitute this guy into there. We get x squared plus, this is negative x plus 1 all over 2. Quantity squared equals 1. As far as an expansion goes, this will be x squared minus 2x plus 1. This is all over 4. If I multiply everything here by 4, this will become a 4x squared. That other stuff will go away, and this will be a 4 over here. So this is times 4 times, or 4 times, and times 4 like that. Probably parentheses there, sorry. Okay. This is one where it's not a 2x squared, it's a 5x squared. So 5x squared minus 2x. Let's try and subtract this over for two forms equals 0. This looks like the one that I factored previously from the example set, only instead of, I think this was a plus 2x before. So I think this factors into 5x and x. Even if this wasn't factorable, quadratic formula is probably where I'd go next, and I need to be set equals 0 to 0 for that anyway. So this will be a minus 1 and plus 3. Negative 5 plus 3 is negative 2. So that seems to work. So if 5x plus 3 equals 0, 5x is negative 3 and x is negative 3/5. That's one x value of an answer. And here, x equals 1 is the other one. We'll substitute both of them for y and its preferred equation, probably that bottom one there. Let's use the x equals 1 part first. Negative 1 plus 1 over 2. So y is negative 1 plus 1 all over 2. That's 0. And when x equals negative 3/5, y is negative, the opposite of, right? This is negative 3/5. So the opposite of negative 3/5 plus 1 all divided by 2. Yep. Wait. Yep. That's 3/5 plus 1, and 1 is 5/5 all divided by 2, which is 8/5 divided by 2, or 8/5 times 1/2, which is 4/5. So the two answers to this, there's 1 comma 0 and negative 3/5 comma 4/5. You start as a fraction, you tend to stay as a fraction, I suppose. Okay, number 54. What are we going to? Problem was 67. Still 14 to go. And these problems go a little slowly, even when I'm doing all the algebra. X squared plus y squared equals 1, and y equals negative 5x plus 13 all over 12. All right, they're really putting their big boy pants on for this one. At least this is a 1. I don't know if that matters. So x squared plus, here's the y squared, equals 1. When we square that top portion, I will get 25x squared minus 130x plus 169. That's the expansion of the top. The bottom is 12 squared, 144. So we'll multiply everything by 144. Oh, geez. 144x squared plus 25x squared minus 130x. Plus 169 equals 144. That's 1 times 144. 144x squared plus 25x squared is 169x squared. That's at least 13 squared. So if it's factorable, a 13 times 13, I'd assume, is in the fold. That's probably the only set. negative 130x, and then subtract 144 over, that's 25. This is looking perfect square trinomial-esque. I'd assume it is. I think this is going to be 13x minus 5 quantity squared. 13 times 5 is 65 times 2 is 130, so that works there. And 5 squared is 25, 13 squared is there. Haha, we got the part. So 13x minus 5 equals 0, or 13x equals 5, x is 5/13. So there's an answer for x, or the solution to the system, with y being negative 5 times this, times 5/13, plus 13 all divided by 12. Still a ways to go when it comes to fractions. That's negative 25/13. 13 is 169 over 13 as a common denominator. This is all divided by 12. Keep in mind, when divided by 12, that also means multiplied by the reciprocal of 1/12. So negative 25 plus 169 is 144. 144 over 13 times basically 1/12. And 144 over 12 is 12. You get 12/13 for y. So when x is 5/13, y is 12/13. That's 5/13, comma 12/13 as an ordered pair. Whew. A lot for that problem. Numbers 55 and 56. First time the center is not at the origin. I don't know how much that will affect overall behavior, but let's go and take a look. We have x minus 3 quantity squared plus y plus 1 quantity squared equals 1 squared, 1. And y equals 2x minus 6. So let's substitute 2x minus 6 for y, but just the y part. So look, I'm going to expand this now. I think it'll be relevant to do. X squared minus 6x plus 9. And then this one, as far as squaring goes, 2x minus 6 goes in for y. So 2x, and negative 6 plus 1 is negative 5. I'm going to save as much time as I can to write I'm going to write as little as I can and save time in the process. X squared minus 6x plus 9 plus, this is 4x squared minus 20x plus 25. No fractions, but the expansion of those two. X squared plus 4x squared is here. Negative 6x minus 20x is here. 9 plus 25 is here. That equals 1. So 5x squared minus 26x plus 33 equals 0. Hoping for factorization. I have no idea if it will or not. Let's try 11 and 3. 5 times 11, no, too big. 5 times 3, so negatives. I think this will work. That's negative 15 minus 11, which is negative 26. Yes, so that one seems to work there. This is equal to 0 as far as factorization goes. If 5x minus 11 equals 0, 5x equals 11, and x equals 11/5. And then x equals 3 is this one. Not final answers. We still have to solve the system. I hope I solved the system on the other one, because I feel like I could solve for x and be done accidentally. So if that's 11, let's start with the 3. Y is 2 times 3 minus 6. That's 6 minus 6, which is 0. So one answer is 3 comma 0. The other one is y equals 2 times 11/5 minus 6. That's 22/5 minus 6, which is 30/5, and that's negative 8/5. So we get another answer. The 3 zeros, one of them, and then 11/5 comma negative 8/5 is the other. I'm hoping for one, I don't know why, but we start with a fraction and we end up with a whole number going like, hey, it's a little cleaner and it feels a little better as an answer, I suppose. I don't know, maybe. Number 56. It's a lot of problems for the same kind of setup each time. I'm very surprised by that. X plus 2, I guess you're getting your practice in. So am I. Plus y minus 6 quantity squared equals 25. And this is y equals negative 2x minus 23. So negative 2x minus 23 will go into there. Let's write this first, because I can expand at the same time. Negative 2x minus 23 minus 6 is minus 29. That's a lot in there. All right, x squared plus 4x plus 4 is the expansion of this perfect square trinomial. This one is going to be 4x squared. Negative 2 times negative 29 is positive. Honestly, the negatives don't matter here. You can make them all positive. It's going to work out. 2 times 29 is 58. Doubled is 116. So plus 116x. And then 29 times 29 is 841. That's a plus as well. This equals 25. So yeah, I plan on going through all those faster. I say that on the last problem, but you're probably like, this is too fast, slow down. How do you do that part? That's the part you kind of would, you'd do on your own. Plus 4 is 845, and then equals 25 here. Subtract 25 from both sides, and you get 820. And then let's divide everything by 5. We get x squared plus 24. X plus 164. It's not a perfect square trinomial. That's a certainty. I don't know if this is factorable. 8. Okay, 164 is 4 times 41. I feel like that one won't be factorable with that in mind. What's this one? Number 56. So I don't think that's factorable. What I want to do is I'll try completing the square if it's not factorable. So x squared plus 24x plus blank equals negative 164 plus blank. So this will be, let's figure out what that is. Divided by 2 and square it is 144 and 144. Yeah, I don't think this one will work out because I get a negative result from that thing. So this becomes x plus 12 quantity squared. Oh, I erased something, sorry. This becomes x plus 12 quantity squared. And then this one is negative 20. Taking the square root of both sides, you get square root of a negative. That's not going to work out. So no real solutions here for number 56. Okay, let's jump to the next page. Reasoning. Consider the graphs shown. They sure are fractions. Explain how you can use the given points to form Pythagorean triples. Well, the center is at 0, 0. So we're going over and up certain amounts there to get things. I don't know. It says identify another point on the circle you can use to form. Okay. Well, so I mean, I see them for what they are. I'm very new to this Pythagorean triple, but not quite the other ones there. I don't know what they want me to say when it comes to answer. Like, because I know that I have an 8, 15, 17 Pythagorean triple, and then that's where it's like dividing by that number, if that makes sense. So when it says use it to find, did it say find Pythagorean triples? To form Pythagorean triples, I'm kind of just more in the... Like, I don't know if this is a unit circle. I guess it is because this is an 8, 15, 17 and a 5, 12, 13 and stuff like that. Like the hypotenuse, in some way, this would be like 15 and 8 and 17. But then they're dividing by 17 everywhere. So I'd say that the denominators in the way kind of represent the hypotenuses of them. So when it comes to the coordinates... The fact that they're rational, I think, means that they would be Pythagorean triples in a way. So dividing by those denominators kind of work themselves out. I don't know if that's kind of working that way, but the way I'm just going to say that out loud is use the numerator, write the two numerators and the denominator of the coordinates for these things here. So we can do, for that first one, this negative 15 over 17. Comma 8 over 17. This Pythagorean triple is an 8, 15, 17. 17 being the hypotenuse, we divide by those things, that works out. That's one of them. The 5, 13, comma 12, 13. I know this one is a 5, 12, 13. So the denominator, once again, hypotenuse. For the other two, I probably don't know how much I know this one off the top of my head, but I've seen it a lot more recently in this book. Negative 40 over 41. The last one I really haven't seen. This must be a 9, 40, 41 Pythagorean triple. And then the last one would be, this one I have not really seen. Negative 12 over 37 and negative 35 over 37, which means this is a 12, 35, 37 Pythagorean triple. So I believe those are the four that you have there. I think that's what they said to form them. I didn't explain it, but the numerators and the denominator kind of represent those parts. Identify another point on the circle you can use to form the Pythagorean triple 3, 4, 5. So this must be a point such as, for the 3, 4, 5, I suppose we can say that as 3/5, comma 4/5. That's an x and a y that we go over with those, the 5 being the hypotenuse and all that kind of stuff. That makes sense when it comes to this. This is a unit circle, so all of these things will give you 5/5, which is 1, or 37/37, which is 1, and that seems to align with it. Okay, number 58. How do you see it? Match each graph with its equation. They don't ask me to explain, so I'm just going to say them out loud. So I'm not going to draw them. Part A and which letter, part B and which letter, C and D. Notice there are lowercase letters here and uppercase letters on the equations. Maybe I'll write out the equations, otherwise you'll be really confused. A is B, B is C, C is D, D is A. A's graph has a center at negative 3, 0. So negative 3 for the x, 0 for the y. That's going to be the C value. All these radii seem to be the same, with 4 is 2 squared. So that's all we have there. So this one is going to be C, x plus 3 squared. Yeah, these are all about the center. Plus y squared equals 4. Part B's center is at 0, 3. So you'll see a y minus 3 in that. That's part D. So x squared plus y minus 3 squared equals 4. And then part C, this graph, match each graph with this equation. So yeah, I'm going based off the graph. 3, 0, so you've seen x minus 3 quantity squared. I mean, I could just write it here. Plus y squared equals 4. That's B. I'll just write these here. B, this was A. No, this wasn't A. This was C. This was D. And it looks like the last one by process of elimination will be A. Part D, this y minus 3. So you'll see a y plus, it's at 0, negative 3. You'll see a y plus 3 in the equation. X squared plus y plus 3 squared equals 4. That is A. CGBA. Number 59. Reasoning. Sketch the graph of a circle whose equation is x squared plus y squared equals 16. Done. I will do that for you, sir. Looks like we need more graphs than just 10. X squared plus y squared equals 16 should look like a center at the origin. And in red, apparently, we will go like that. Let's change it to blue. Then sketch the graph of the circle after the translation. 2 to the left and 4 down. That's what that's saying. Let's change that color. So 2, whoops, it's not like that. Let's do that again. 2 to the left. Oh, this is tough without having a center. Hold on. Let's do that again. Let's group that as one thing. Turn that green. Let's go 2 to the left and 4 down. Now, it's probably that we don't necessarily copy and paste these. If I plotted the center like that, that would work in its own right. So about right there. What is the equation of the image? Make a conjecture about the equation of the image of a circle centered at the origin after translation m units to the left and n units down. So the original equation was x squared plus y squared equals 16. This one, with 2 to the left and 4 down, is x plus 2 quantity squared plus y plus 4 quantity squared equals 16. So my conjecture is anytime I go m units left and n units down, my conjecture is that the equation, m units left, would be x plus m quantity squared, and then n units down is y plus n quantity squared equals 6 of a circle centered at the origin. I guess r squared. R squared is that equation. Left and down, we have to make the pluses there. It says 2 left. It didn't say 2 was negative. It just says 2 left, right? So make sure you note that difference. All right, number 60, thought-provoking. I'm glad we didn't have like other proofs on top of our stuff. A circle, besides the prove or disprove coordinate ones. A center circle HK and contains point AB. Write the equation of the line tangent to the circle at point AB. Okay, quite interesting. So we have, like, in a graphing form here, center at HK and a point on the circle. This circle, point is AB. As far as an equation goes, oh, they want the equation of the line tangent to the circle at that point. But as far as this equation goes, let's see how I want to say that. Well, we have to work the slope. So to do equation of a tangent line, we have to understand that a tangent line is perpendicular to the radius. If this is our radius and this is our tangent line, it'll be perpendicular to it, right? That's what it kind of needs to look like, one that's intersecting like that. So perpendicular means opposite reciprocal slope of the radius that you have. So the slope of my radius, slope of the radius, Mr., if that's R, is going to be y2 minus y1 over x2 minus x1. Give me 1 sec to pause for something here. Okay, so there's that slope of this one. Now, the slope of the line perpendicular, this is going to look weird. The slope of the line perpendicular to this, we have to take the opposite reciprocal. So the slope of the perpendicular line, we flip the fraction, and then we also change the sign. Now, the sign changes in just one spot, whether it's in like the numerator or the denominator. That means that this can apply to the numerator here. I can make the h positive and the a negative, so like h minus a over b minus k. Hope I'm doing this right as far as like what kind of answer they're going to want. This is the slope of the perpendicular line to it that goes through there. When it comes to doing something like point slope form for an equation, we use y minus y1 equals m times x minus x1. I'm just going to go ahead and do that. They said write the equation of the line. I was hoping for the word and, but they didn't say whether it's slope intercept form or point slope form. If it's point slope form, I can say y minus, my y1 is b, that's the point that it's crossing through, equals m, this is my slope, times x minus x1, x minus a, like that. So that's one version of the equation that's in point slope form. If I was in slope intercept form or wanted to do that, I could distribute this into the x and the a. That would look quite crazy as an overall answer with this thing. I don't know how much I actually want to see that answer to that thing, but I'd say point slope form is the one that's going to make me most sane as an overall, and I think I like this one most for it. So I'm going to go ahead and leave that there. I don't plan on doing further distribution. Okay, number 61. 7 more questions, I believe. Number 61, the vertices of triangle XYZ are x equals 4, 5, y is 4, 13, and z is 8, 9. Find the equation of the circle circumscribed about XYZ. Justify your answer. So with this kind of problem here, the one issue I kind of have is with my graph paper stuff that the y is at 4, 13. That's a little off the graph, but I'm at 4, 5 for x. Z is 8, 9. So x and z, and y is at 4. It was 4, right? 4, 11, 12, 13, kind of like that. And that's a triangle that we have. And we are going to find the equation of the circle circumscribed about it. So that means we're going to be able to draw a circle around this thing, which means we need to find where these, oh, I'm kind of now recalling what kind of thing we have to do here. This is something from chapter 6. But we have these 3 points, right? To find the equation of the circle circumscribed around this thing, we have to recall what kind of thing that circumscribes a triangle. To circumscribe a triangle, we would have to find the circumcenter, I believe, right? Circumcenter. So we'd have to find the perpendicular bisectors of these three guys here. And I think it's going to be a simple one. I believe if this is at 5 and this is at 13 and this is at 9, then this distance here is 8. So I think this in and of itself is a perpendicular bisector right here. Because that's exactly, this is 4 up and 4 up, right? These are congruent to each other. We'd have to get another perpendicular bisector such as this one. This is a slope of 1, so this is a slope of -1 through that midpoint. I think that the circumcenter's right there. I'm speaking a little fast, but this is the stuff that was in chapter 6. The circumcenter is the construction of the point of concurrency of the perpendicular bisectors of your object, because this place is going to be the same distance away from all of these points. If you want something to circumscribe the object, it needs to be the same distance away from all points as if you're going to draw a circle with a radius. So basically, this circle has a radius of going out here to touch x, y, and z at the same time like that, and that radius is 4. So we have the center, we have the radius. The center is at, it looks like 4, 9. The radius is 4 this way, 4 that way, or 4 that way, gets you all the things there. So the equation will be x minus 4 quantity squared plus y minus 9 quantity squared equals 4 squared being 16. I think that's going to be the equation there. Number 62. Your friend claims the equation of a circle passing through the points -1, 0, and 1, 0 is that nonsense. With center at 0k, is your friend correct? Explain your reasoning. The equation of the circle. It might actually be. We had another one with the -3, 0, and 0, 3, and it passed through these other 2 point things. I don't actually know. Center at 0k. Let's see what they're asking for here. Let's do this. Let's take x squared minus 2yk plus y squared equals 1, and let's go ahead and get it in. It says the equation of the circle. So let's get this one in standard form and see what's going on here with the center at 0k and all that stuff. But the equation of the circle passing through those points in particular, do we just need to substitute those in there? I'm not quite sure. Let me think through this problem a little bit. That's a k value. This is no factor in completing the square. Maybe I can complete the square with this thing. What if I rewrite this as x squared plus y squared minus 2yk, I don't really know, equals 1. As far as, let's write it like this. X squared plus y squared, I'm going to write minus 2ky. I want to treat k more like a constant value with this, and then I'm going to complete the square within this guy. 1 plus blank. So in this case here, negative 2k divided by 2 is negative k, and squared, sorry that I wrote that kind of weird. Squared is, negative k squared is k squared. And so we're going to add a k squared over on this side as well. Okay. So this factors down to x squared plus, and this is y minus k quantity squared, and this is k squared. I'm going to write it as k squared plus 1. I don't know which one's better than the other one. So when it comes to this here, this center is absolutely at 0, k. So your friend's bit checks out from there. I feel like there's a faster way for me to go about that part. I don't really know. But this is your r squared thing, or your radius. Now, it says it passes through the points -1, 0, and 1, 0. For that to work, let's try and plug in. So let's try -1, 0. Good question. -1 for x. 0 for y. And let's see if it equals k squared plus 1. -1 squared is 1. Negative k squared is positive k squared. So that is 1 plus k squared. Let me maybe keep it as 1 plus k squared, because it looks like that's going to clean things up a little bit faster for me. So 1 plus k squared here. And this will be 1 plus k squared there. Anyway, that one checks out. This is 1 plus k squared. And I'm doing this one without a graph, but that one seems to check out. And then at 1, 0, it will also check out, because all we're doing is just doing 1 squared this time. We'll still get 1. Negative k. 0 minus k is negative k. 1 plus k squared. 1 squared is 1. Negative k quantity squared is k squared. And that one checks out as well. So your friend is correct. I feel like there are different ways for me of going about that, substituting things earlier. But I wanted to actually pinpoint the center portion. And I got that through standard form of the circle. That's how I worked it out. Okay, 63 to 66. Those are the second to last. That's the penultimate 4, I guess. Before the final one, we are going to use the equations to determine whether the line is a tangent, secant, or a secant that contains the diameter, or none of these. Interesting. So, the first one, we have x minus 4 squared plus y minus 3 squared equals 9. I feel like with these ones, we have two options. There's an algebraic version and a graph version of this one. If I graphed them, and my scale would have to be perfect, which it's not too bad, but if I graphed them, I could see it. What I could also do, I might want to graph them because they're also asking, if it's a tangent, that means plugging in 6 for y would give me only one solution for x. A secant would mean plugging in y would give me 2 solutions for x, and a none would be plugging in 6 for y would give me no solutions for x. However, that's algebraic for that part. It doesn't explain how solving algebraically shows you the secant that contains the diameter. So that's where I feel like graphing it's going to be the one that I'm better off with in these cases, because if it has 2 solutions, I don't know if I can guarantee with my numbers. I kind of could by a radius, but I don't. Oh, you know how I could? The y values would probably be the same because y equals 6 is a horizontal line. These other ones, though, are not horizontal lines. So it might be best that I just do the graphs as long as they fit. So this one, I'm not going to write out the information, but I'll say them out loud. I'll just kind of mark this for what they are. The blue one is the circle. I have a center of 4, 3. I have a radius of 3. So with that 9, that's now going to look like square root of 9 is 3. So radius of 3 is going to look like that-ish. And I think the ish needs to look close enough, but I think we'll be good. So radius of 3 like that. And then y equals 6. Now y equals 6 is going to be this guy, a horizontal line going across 6 like so, right there. Now it should only touch once, just at that point 0, 6, which means if I plug this in, I'd be getting the same thing. So I think that that kind of works out that way. This is going to represent a tangent line. Number 64. Yeah, I feel like graphing is kind of the way. For the everything else would have been fine as long as they didn't say the diameter part, but they did. So I think I do have to graph it. X plus 2 quantity squared plus y minus 2 quantity squared. And if I'm not thinking of something else, let me know. Without overdoing the problem where you're finding the distance across the diameter and stuff. I'm not trying to do any of that. So let's go ahead and graph these two. Hey, it's good to practice graphing circles even without writing the info, and graphing lines. So this one will be blue. This is -2, 2 as a center. So this is right there. The square root of 16 is 4. So this has a radius of 4. 1, 2, 3, 4. Y equals 2x minus 4 we'll do in green. -4 is the y-intercept. We got a slope of up 2 over 1. This is where drawing the scale is super important. It looks like it actually doesn't hit. This is something I could confirm algebraically. I probably do not plan to. It doesn't actually look like, I mean, I say it's close, but close ain't cutting it to actually believe that it would hit and forcing it. No, I'm not going to force it. This is none of these. None of these. I'm guessing each one is going to be hit, or each answer is going to be touched once. So we have a tangent and a none of these. We're now looking for the secant, and secant with a diameter is my guess. I have no idea. Number 65, we have x minus 5 quantity squared plus y plus 1 quantity squared equals 4. And this y equals 1/5 x minus 3 is further encouraging me that I should be doing these graphs because that is a fraction value. I don't think I plan on doing anything with fraction values in expansion anytime soon. So this is y equals 1/5 x minus 3. Okay. In blue, we have a center of the circle at 5, -1. The radius, square root of 4, is 2. So let's see that we hit them. I definitely think this will be a secant based on what this equation looks like. Y equals 1/5 x minus 3 is -3 here and up 1 over 1, 2, 3, 4, 5. I've determined another way that we can do this secant with the diameter part is the diameter would have to go through the center, but that would still require that I do more points, more tests to figure out if the HK, I would have to figure out if plugging in H for X and K for Y in this equation gives me a true statement. So I suppose that's possible, but this graph also gives me what I need. In some way, this is a secant and just a secant, not a secant that goes, that's a diameter. And the last one, 66, not the last problem, but the last one of these sections, it's the second to last question. X plus 3 quantity squared plus y minus 6 quantity squared equals 25. And then this is y equals, once again, a weird fraction, -4/3 x plus 2. Further validating that graphing should be the way to go here. Hopefully your graphs of circle stuff is making a whole lot of sense without me writing the information, but I'm pulling out the information, right? So this is going to be -3, 6, radius of 5, 1, 2, 3, 4, 5. Kind of like that. In green, -4/3 x plus 2. Hoping that we hit the center here. Plus 2. Boom. We hit that point. Up 1, 2, 3, 4. Left 1, 2, 3. It hits the center. So it looks like it's exiting. It's going in, coming out. It's a diameter. They really had to think up that problem, didn't they? Not try stuff till it works, but making sure they know what they're doing. So this is that guy there. That's a secant that contains the diameter. Secant that. So each thing was hit. Contains, or each option was hit. I'm guessing graphically is what they would have wanted. All right, and the last question, number 67, reasoning. Four tangent circles, that means they touch each other once at those points, are centered on the x-axis. The radius of circle A is twice the radius of circle O. The radius of circle B is 3 times the radius of circle O, and C is 4 times the radius of circle O. All circles have integer radii, and the point 63, 16 is on circle C. What is the equation of circle A? Explain your reasoning. So anywhere on circle C can be some sort of 63, 16. I don't know if it's farther out, closer up, whatever it is, but the point remains that it needs to be at least, well, 16 means it needs to go up a certain amount, but at the very most, it can only be like 63 away or something like that. So what I want to reckon here is, like, I'll use the letter R in case I need to use X later and it interferes. I might have to sneeze here. If this is R as a radius, this distance so far is R units out. A is twice as big, so this would be 2R plus another 2R, which is 4R. B is 3 times that R, so 3R plus 3R is 6R. And at least to center C, that's an additional 4 times more of this R, so it's an additional 4R here. I don't know where I'm going with this specifically just yet. I just know that this radius for C, or the center for C, would have to be this distance here. So center for circle C, center C, is at R plus 5R, 11R, 15R. It's at 15R comma 0. The only place I can think of where to go with this, all circles of integer radii, and the point 6316. The only thing I can think of where to go with this is there's another point on C, which is 6316, and somewhere we need to do the Pythagorean. Well, this time I'll do distance formula. I think this one applies a little bit better because there's an R here. So the distance of circle C, the radius, I should say, because it's not the original one, but the radius of circle C is the square root, this is distance formula, square root of let's just do 15r. 15r minus 63 quantity squared plus 0 minus 16 quantity squared. So that'll be square root of, that's a lot to expand. I have to think about what I want to do with this as a whole when I get there. But this will be, maybe I can keep it as that. 15r minus 63 quantity squared. This will be plus 256 there. Now, I never planned on actually doing a square root bit here, but I need to make sure when I take the square root of this, I get a whole number. So I have to figure out which whole numbers can fit within this set of 16 up. That means it needs to be a number more than 16. A leg that goes 16 up in a right triangle means the hypotenuse needs to be more than 16. So I need to choose numbers that are more than 16, such as, if it needs to be a perfect square, it needs to be 25 or 36 or 49 or something like that. I don't know if I'm doing this right, but I'm just figuring out some ideas of that. It's a little bit of guess and check what I'm going to try. I want to see if this 15r minus 63, hold on. When I say 25, that's the hypotenuse, and when I have to square those values, I guess I was going to try something in terms of square root stuff. I might have to do more with this problem, or I might be doing it kind of strangely. It says, what's the equation of circle A? I'm definitely still working on this thing with C. Let me expand that anyway. Do I have to expand it? I don't think I have to expand it. Okay, so here's what I'm going to do. I'm going to compare 15r, there's probably a shorthand way I'll do it after I try this first one, plus 256 equals, wait, why did I say 25 here? Because that's 5 squared. I don't need to square that number. I just need to have some number that's bigger than 16 that'll work there. So let's call this the radius of C. Let's just coin this with an X now because we haven't used it yet. So ignore the 25 portion. Any number bigger than 16 could be possible, I believe. That's all we got to figure out. Let's kind of reckon what this X would have to be by squaring both parts, but there's still that R. R, by the way, not R, 15... R plus 4, 5R plus 6R. 11R has to be less than 63. I'm not doing too well with this one. I feel like I'm not doing too great on what I want to do with the problem. I thought it was going to just be an easy problem. If I squared both sides, I have two variables here. That's kind of the one issue. This would say 15R minus 63 quantity squared. I still haven't done anything with that. Plus 256 has to equal x squared. And I need to make sure that that x squared is going to be something nice. Let's see. Let's subtract the 256 over. 15r minus 63 quantity squared equals x squared minus 256. Okay, I think the bottom line here is this. I'm going to test values of x. So when I square it and subtract 256, I still get a clean value out. Now, there's one value that I had in mind based on like Pythagorean triples. I think I was going to try 450. So x would be 15, I should say. Oh wait, x can't be 15. Sorry, x would be I can't think of it. Let's try values of x here. I need x squared minus 256 to be a perfect square. Perfect square. So let's try some values. They need to be more than 16 to start. So 17, this is what I'm going to show you. X squared is 289 minus 256, which is 33. That's a no-go. And then we would kind of keep going off of that one. Now, feel like the next one that'll show up, shoot, I had a value in mind. I can't remember how I was going to come up with it. But is this really guess and check? I don't know. But if it's really guess and check, I want to see that I can work this thing out and confirm that even 63 would work. I don't know if it will. I haven't done anything with the 63 yet. Oh, I kind of have right here. You solve for R with the 63. So let's try those. Let me keep trying ones in the calculator. Let me actually pull up. I'm probably doing the problem wrong, and I feel bad. So let's pull up. I didn't actually pull it up. But I'm going to do this in kind of a shorthand fashion. I'm going to do x squared minus 256 and try values from 17 onward and see which one gives me a perfect square value. So 17 doesn't work, 18 doesn't work, 19 doesn't work, 20 seems to work. 20 minus 16, whatever, 20 squared minus 16 squared gives me a perfect square value of 144. So 18 is a no. 18, 19, I don't think 20 was the one I was trying to get before. But 20, that would be another kind of Pythagorean triple here. Be part of the 3, 4, 5 maybe. So this will be 400 minus 256, which is 144. So let's plug in that for x. Let's solve for r. Now we'll have 15r minus 63 quantity squared equals 144. The way that this works out is now I can take the square root of both sides. Maybe there was something I could have done with expanding this, and I just didn't bother with it, and I apologize to that. But we take the square root. Now we have 15r minus 63 equals 12. Add 63 to both sides. You get 15r equals 75. Divide both sides by 15, at least as an integer. You get r equals 5. So the radius is 5 for this set. Well, the original radius is 5. So if the original radius is 5 right here, we need the center for circle A, and we need to get its radius as well. If r is 5, then the radius for A is 2 times 5, that's the diameter, is 2 times 5, which is 10. So radius is 10. The center is at something comma 0, right? It's going to be at r plus another 2r. So 3 times 5 comma 0 or 15 comma 0. So A, the center for circle A. So the equation for A is going to be x minus 15 quantity squared plus y squared equals 10 squared, which is 100. That should be that one there. I really feel like there were other ways to do it outside of the guess and check component. That's the part that really kind of threw me off for it. But it still got me there. So there's probably something at this stage, either any of these stages here. There's something at this stage where I probably could have done a different manipulation to figure those things out, but trial and error incorporated the following. The number had to be more than 16, it had to be an integer, and it had to lead me to a perfect square when I got here. The first 3 didn't pan out, the next one did. I used my calculator to kind of assist me on that one, but there is a final answer. All right, guys, and we are past the 2-hour mark. Not as quite. Oh, you don't have this thing anymore. I'm sorry. That's still supposed to be there. Anyway, that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching, and that's concluding the chapter as far as new material goes. Anything else after this is forms of review, chapter test, are you ready packets, things like that. But y'all, take care. I will see you in the next one.